Great. Welcome to what I'm calling Lecture 1.5 of the fourth week of Introduction to Logic Online, Philosophy 1500.02. In this lecture, we're going to be talking about well-formed formulae, rather. These are rules, right, that govern how we can put together symbols and statement letters or statements. Right, so the idea is going to be that there are certain combinations that we're going to call syntactically correct, right, and there are other combinations that aren't syntactically correct. Right, so one way to sort of think about this is on analogy with English. Right, so the man is on the roof is syntactically correct, right, it's meaningful. The symbols in that particular order, like the man is on the roof, those symbols, right, they make a sentence, right? But the man of the on, right, not syntactically well formed, right, syntactically incorrect, it's nonsense, right? The symbols going together in that way don't make a sentence in English. Similarly, in propositional logic, what we're studying right now, right, there are certain ways we can put together symbols that are meaningful, right, that are well formed, right, and other ways that we can't. Right, so we're going to talk about some rules in this lecture that govern the formation of well-formed formulae. All right, so the general idea is that some symbols can be put together and others can't, right? And what we want to do is figure out which symbols can be put together in which ways and which ones can't. All right, so one thing that's going to be really important is that statements come in two different kinds, right? So earlier in the first lecture, we talked about simple statements and complex statements. Here's just a review of what those are. Simple statements, right, contain no other statement as a component. So examples of these are like P, Q, right? In English, maybe something like the man is on the roof, right? Or Sally likes skipping. I don't know. Those are simple statements, right? They don't contain any other statement as a component, right? Where statement here sort of corresponds to simple sentence, right? On the other hand, we have complex statements, right? And these contain at least one simple statement as a component. So examples, tilde P or not P, P and Q or P dot Q. If P and Q, then R. Right, so each of these contains at least one simple statement. So the second and third one, this is, I take it, clear. Right, so the second one has both P and Q. The third one has both P, Q, and R. But what about this first one, not P? Well, it contains a simple statement, right? P, right, and it's built up out of P and tilde. Right, so it's a complex statement. One other thing to note here is that what goes in parentheses, right, counts as a complex statement. So P and Q is itself a complex statement, and it's part of a complex statement or a component of a complex statement. In this third example, if P and Q, then R. Right, so highlighting, right, P and Q, right, and in P and Q, P and Q in if P and Q, then R is itself a complex statement, right? So complex statements can be built out of complex statements, right? But ultimately it bottoms out in simple statements, right? So if P and Q, then R, right, is built out of P and Q and R, right? And ultimately P, Q, R. All right, so another reminder, we have these symbols. One thing that we've talked about sort of in passing is that they come in sort of two different types, right? So first we have one-place operators, and then we have two-place operators, rather. So we have one-place operator, right? And this means it attaches only to a single statement, right? This could be a complex statement or a simple statement. And that's the tilde, right? It corresponds to not, it's not the case that. Right, and then we have our two-place operators, and these attach to two statements, right? Hence two-place. So we have dot for and or but, wedge for either or unless, the horseshoe for if then, provided that, and so on, right? And then the triple bar for if and only if is equivalent to is necessary and sufficient for, right? So the one-place operator, tilde, attaches only to a single statement. That statement could be simple or complex. And then the two-place operator is attached to two statements. Again, these could be simple or complex, right? And we'll see examples of all of these. Right, so these are the rules that we're going to talk about. I'm going to give them to you all at once, and then we'll go through them one by one. But first, statements cannot be combined without an operator between them. So we couldn't put together just A and B, right, like right next to one another without an operator in between them. A tilde cannot immediately follow a statement, but it can immediately precede any statement. Right, so we'll see examples of this. A tilde cannot immediately precede any other operator. Again, we'll see examples. A dot, wedge, horseshoe, or triple bar must go immediately between statements. And parentheses, brackets, and braces must be inserted to prevent ambiguity. Right, so we're going to talk through all of these, so if these are like nonsense to you right now, that's fine. Okay, so here's our first rule. Statements cannot be combined without an operator between them. So this is, I think, best understood with like examples and then something I'm going to introduce on the next slide. So here are some bad examples, right? Some things you can't do, some things that aren't well-formed formula or woofs, right? So AB, right? That's not good, right? We have to have an operator between those. Which sort of operator, you might ask? Well, think about it. It has to be a two-place operator, right? Because it's putting together in some way A and B. Also bad would be A left parentheses B dot C right parentheses, right? So A is a simple statement, B and C is a complex statement, right? But statements cannot be combined without an operator between them, right? So we need something between the A and the left parentheses, some sort of operator. Again, it's going to be a two-place operator, right? Because we're going to be putting A and B and C together in some way. So compare those to the good examples below, right? A dot B, A dot left parenthesis, B dot C right parenthesis. Right, so here the statements have been combined with an operator between them, so they satisfy this rule. These are good examples. Right, so if you're symbolizing something, and you end up with something that looks like AB or A left parentheses, B dot C right parentheses, you've done something wrong, right? They shouldn't look like that. Good. So here's something to note, right? And it's something we sort of mentioned in passing. Not just any symbol is going to do, right? Not just any operator, right? Statements must be combined with two-place operators, right? So A tilde left parentheses B dot C right parentheses is bad. We don't want that, right? So remember, tilde is a one-place operator. It attaches to a single statement. You can't use it to put statements together. Right, so we need something between A and tilde, right? That's a two-place statement, or a two-place operator, rather. So dot or horseshoe or wedge, right, or triple bar would work. All right, so here's something that it might be helpful to think about when we're thinking about how we can put statements together with these symbols. It might be helpful to think of the operators as having like slots, right, where statements go. Right, and what's important is that these slots must be filled by statements, right? So in our one-place operator, the tilde, right, it attaches only to a single statement, and it has a single slot on its right side, right? So in order to make a well-formed formula, right, we have to put a statement in there. Okay. And similarly for the two-place operators, right, these attach only to two statements, so we can think of them as having slots on their left and right side. Right, so we have slot, dot, slot. Right, so something has to go in the left slot, something has to go in the right slot, and what goes in those slots have to be statements. They could be simple statements, they could be complex statements, but they have to be statements. Right, same for the wedge, the horseshoe, and the triple bar. Right, you have to put statements in those slots. If you don't have a statement in that slot, right, because perhaps you have nothing in that slot, right, or you have like another operator, that's not good, right? That's not well formed. So we'll see examples of this here in a second. But I hope that this idea of the operators having slots, right, where statements must go, right, is helpful. All right, so we're going to go through the rules, right, and I'm going to use this sort of slot stuff to help. So a tilde cannot immediately follow a statement, but it can immediately precede any statement. All right. So let's think about where the slot is with the tilde. It's on its right-hand side, right? So we're told that a tilde cannot immediately follow a statement, right? But it can't immediately precede any statement. So let's take the second conjunct, that it can't immediately precede any statement first, right? So we have our slot with our tilde, right? And we can put a sentence, or a statement rather, in there. So in our first example, we have tilde A. So we've put a simple statement into the slot. In our second example, we have tilde A dot B. Again, we've put a simple statement into the slot, right? And in our third example, we have A dot tilde, left parenthesis, B dot C, right parentheses. So here, we've put a complex statement into the slot, right? B and C, right? And the tilde ranges over that whole thing, right? So it says it's not the case that both B and C. Okay, so let's take the first conjunct, right? A tilde cannot immediately follow a statement, right? So here we have A tilde, right? So the slot's on the right-hand side. We can't just put an A on the left-hand side of the tilde, right? Because there's no slot there. Similarly, for our second example, A dot B tilde, right? There's no slot and the tilde on the left-hand side, so we can't put a statement there. And then similarly for our final example, A dot left parenthesis, B dot C right parenthesis. Again, no slot on the left-hand side of the tilde. We can't put B dot C there. Right, so here's making it sort of explicit what's going on. When that tilde is there, it has that slot. Here the slot's empty, right? And I've highlighted that to show that there's nothing there, right? There's a slot, but nothing in it, right? And that means that the statement is ill-formed or not well-formed. All right, so a tilde cannot immediately precede any other operator. Remember, slots have to be filled only by statements. Right, so this rules out A tilde dot B. Right, so we have our tilde there, and then we have a statement or an operator following it immediately. Dot. Right, so we can't put dot B in the slot for tilde. Right, we can only put statements, and dot B is not a statement. Right, because think about what the dot is. Right, it's a two-place operator. Right, and for it to be a statement, a complex statement, both of those slots, right, have to be filled. So what we have in effect is A tilde empty slot dot B, right? Empty slot dot B is not a statement, right? So it can't go in the slot that has, or in tilde slot, right? Similarly for A dot left parentheses B tilde dot C right parentheses. Right, so again, we have our tilde, right? We have a slot, right, that is supposed to be filled by a statement, but then we have dot C. Dot C is not a statement, right? So we can't put it in tilde slot. Right, so again, I've highlighted this to make it clear what's going on. Right, dot B, dot C, they're not statements, right? So they can't go in tilde slot. All right, so our next rule, a dot, wedge, horseshoe, or triple bar, that is a two-place operator, must go immediately between statements. Right, so this rules out A, B, dot. Right, so there are two statements there, but the dot's not between them. Right, so sort of, so that's clearly bad. Our next example, A, left parentheses, B, horseshoe, dot, C, right parentheses, not, or tilde rather. That's bad for all sorts of reasons, right? So one reason we've already seen, we have our tilde there, right? It slots on the right, but there's nothing there, right? It's empty. So that's bad. But also we have our horseshoe and our dot, right? They're two place, but there's no statement, right? So in the one case, we have dot C filling the horseshoe's right slot, right? That's not good. That's not a statement. In the other case, we have B horseshoe filling the left slot of dot, right? Also not good. And can you see another problem here? Right, so there's one more problem. It's that we have A left parentheses B, right? A is a statement. It looks like it's supposed to be attached to a statement, right? But there's no two-place operator there. So remember, slots, right? All right, and then finally, parentheses, brackets, and braces must be inserted to prevent ambiguity. Okay, so this is sort of tricky. What I'm going to try to do is get you to see that there's ambiguity here and that we want to resolve it. Because it's ambiguous, right, it could mean different things, and it could be true in different circumstances. Right, so consider the following statement, A wedge B dot C. Okay, so there are two things that this might mean. Right, it might mean left parentheses A wedge B right parentheses dot C, or it might mean A wedge left parentheses B dot C right parentheses. Okay, but note these are different. Okay, so let me try to convince you of that. So we'll use an English example. So for our first one, this corresponds to something like it's raining or it's snowing and it's cold outside. Again, it's raining or it's snowing, and it's cold outside. Right? The second one corresponds to something like it's raining or it's snowing and it's cold outside. Right? So can you hear the difference in meaning? Right? So another sort of way to convince you of what's going on here, that these are different, right, is to think about what would have to be the case for each of them to be true. Right? If they were true in different circumstances, it would be the case that they don't mean the same. Right? So our first one, right, consider it's raining or it's snowing and it's cold outside. What would the world have to be like for that to be the case? Well, for one thing, it would have to be cold outside, right? But it could either be raining or snowing, right, for that to be true. Right, so if it's raining and it's cold outside, it's true. If it's snowing and it's cold outside, it's true. Okay, so how about this second one? It's raining or it's snowing and it's cold outside. Right, so one way for this to be true, right, is that it's snowing and it's cold outside. Right, but another way for it to be true is just if it's raining. Right, so maybe it's raining and it's warm. Right, so it's raining or it's cold and it's snowing, it's snowing and it's cold outside would be true even if it were just raining and it were warm outside. Right, so do you see how these could be different, or how these could be true in different circumstances? Right, so that shows that they don't mean the same. Right, so to prevent the ambiguity, right, of A wedge B dot C, right, we have to put parentheses to block things up, right, into different complex statements. Right, one way to do it here would be with our parentheses around A wedge B. Another way to do it would be B dot C. Right, so you might wonder, well, which is the right way to do it? Well, it depends on what you're translating, right, or what you're symbolizing. If you're symbolizing it's raining or it's snowing and it's cold outside, the first one, left parentheses A wedge B right parentheses dot C, is correct. Right, but if you're symbolizing it's raining or it's snowing and it's cold outside, then A wedge left parentheses B dot C right parentheses is correct. Right, so which one's correct depends on what it is that you're doing, right, which one you're symbolizing. Okay.